Example 4, write each complex number in its alternative form using a calculator if you need. Okay, so if you look at example A, I can see that I have r and theta. I have r and theta. That means I'm in polar form. That means I must need x and y. They're asking me to change it to the other form. So let's change to the other form. I need x and y. X equals r cosine theta, and y equals r sine theta. In degrees, need to be in degrees here. So 6 cosine 115 and 6 sine 115. Looks like we would have our x value is negative 2.54 and our y value is, oops, I don't want to write it in that form. I want to write it in this form. Negative 2.54 plus 5.44i. Rectangular form shows me the x and the y coordinate. And so we look at the other part. The other part has x and y. That means we need r and theta. They're asking me to change to the other form. So if they need r and theta, that means we're changing to polar form. So we know our formula for r, square root of 5 squared plus negative 4 squared. That's square root of 25 plus 16, or square root of 41. I'd probably just leave it as square root of 41 and not worry about the decimal version. You can if you want to. As for theta, tangent theta I know is y over x. And so let's do an inverse tangent on that. Inverse tangent, negative 4 fifths. That negative doesn't really do anything for me. It's just talking about where we are. So here, when I get that out of the calculator, I see a 38.7 degree angle where tangent is negative. But let's think about where we are. We can tell specifically if x is positive and y is negative. What quadrant does that put me in? X is positive, y is negative, puts me in the 4th quadrant. So I've got a 38.7 degree reference in the 4th quadrant. So that means theta is 321.3. So I've got r is square root of 41. I've got theta is 321.3. So polar form is going to be square root of 41 cis 321.3 degrees. You put it in a longer form if you want to. Longer form is going to look like square root of 41 times cosine 321.3 degrees plus I sine 321.3 degrees. Same thing.